So what I'm going to need to do is write these things in here. So we need to calculate the direction that we're supposed to be in, and we're also going to get the magnitude. Let's start with the direction. Alright, so if object.m, what? So I have a bool m radial and f vector m direction. So I'm going to look for a water flow object. O that m radial equals object is radial, and O dot m direction is object get direction. Now get direction is going to transform this thing. I should be able to just use it. I'm going to want to transform it by the actual object that's attached to first, though. Let's go ahead and fix that in blueprints before I forget about it. Because right now it's just rotating a thing around. We need to rotate it, transform it into the component space, and then we need to rotate it. Or we just need to take that vector and rotate it into component space, because we set the direction based on the constructor blueprint script. Gosh, all of a sudden I'm just hit with a wave of, I don't want to do this. Just like, man, that sucks. Well, I'm just going to sit here and keep working anyway. Work on another subsystem? Nah. That's a good way to forget half of what you're doing and then never come back and finish something. At least for me it is. It's just one of those things you gotta deal with. Let's see, so get the current component to world transform. Come on, I just want to get the fucking rotator off of this thing. And in C++, transforms have get rotator on. And in blueprints they don't. Come on. Alright, so you have to right click on it and grab the rotation. Now that is stupid. That is not how things should be. Because they should be both. Like, you should not have to know to split a structure pin to get something on there when there is a function in C++ land that does the... That's just idiotic. Alright, so we have our direction properly now. So this is going to be a world space direction. We have to convert from world space to actual space? Is that what's going on here? So we need to convert from world to non-world space because we're going to convert back. X step and Y step. Did you think this water stuff would be this hard to do? With what I'm doing, absolutely. I mean, it's a whole water system, right? If it was simple, everybody would have it. I mean, people write their doctorates on flow field stuff and all sorts of stuff, right? You know, we're talking about people that spend 2 years working on all sorts of ridiculous stuff just to come up with oh, here's a faster way to compute it, So it's definitely something where that's taking this long to get it into the game it's supposed to. We're not supposed to be finished with this. Alright, so if I need the actual direction here, so we're going to have f vector, let's say start and end. Let's say start equals so I have the position, and end is going to be object.mPosition plus object.mDirection times 100, because I can. So it's going to be f vector. So we're going to get the grid square for world position for start, and we're going to get so sx, sy, get it for the end position, sx, sy, and so f vector 2D parent direction is going to be ex minus sx and ey minus sy, and then we normalize that. So that should calculate this in texture space. Yeah, it's like any physics class. It's like, how do we approximate friction? Well, there's a static and dynamic coefficient of friction. You're like, well, but how does friction actually work? And you're like, well, that's a completely different story. That's always the fun part of physics stuff. You're like, well, we can just ignore all this other crap. This other thing is so much more powerful that we just, who cares? Who cares what those values are? They're relatively zero. So just chuck them in the garbage. I'm like, alright then. Alright, so if it's a radial object, then the vector distance is going to be the center of this object. So we have left, right, top, and bottom. So we're going to need to get the N32, let's see, CX and CY, and I think we're going to need that for everything. Or we might as well have it for everything. So it's going to be object in position, and then CX, CY. Alright, so if it's a radial object, then f vector 2D dir is going to be what? It's going to be x minus cx and y minus cy, and dir dot normalize so if dir dot size squared equals 0, then dir equals parent direction. So we'll have at least some sort of direction here to write in, or we can just not write in the direction. That's probably something we could do either. Otherwise, dir equals parent direction. Alright, so we'll have f vector 2D dir, and we'll say dir equals that vector, we'll normalize it. Otherwise, dir is the parent direction. I mean, honestly, if the dir is nothing, then we don't have a direction. We're fine. And what are we going to do? We're going to write this direction in there. Into our pixel array. So we're going to say calculated flow pixel. Pix equals pixels subindex. Pix.pos equals dir. And pix.mag equals 1.0f. And this is kind of copy pasted, but the copy pasted stuff is all this, and I don't want to chuck that out into something else just yet. We'll see what it looks like first. And we should actually write the flow objects here last, like this. This should be 5 and this should be 4. Because we don't want to do our tiered average until after we've already put everything in there. Or maybe we do. We'll mess around with that. So let's go ahead and see what this looks like. Yeah, that's one of the other fun things about games, Lucas, is that everything in a game, like you expect all this crazy stuff to exist, right? Like even a game like Dark Souls, you need like super awesome physics collision on stuff. You need beautiful environments. You want, water physics, for when you're like walking through water and all this crazy stuff. And every one of those things could be its own product, right? Like every one of those features that go into these games can literally be, like the pathfinding, the AI, even just like the asset loading or asset pipeline. All of those are all super complex pieces, and they all have to come together properly to actually get a game to work. Just lying in bed. Well, hopefully I can just get some of this stuff done. And I imagine Adam is streaming, right? Or is he getting close to it? No, he's not on yet. So I mean, you gotta stay up for Adam's stream, right? Or what? He's not streaming. All right. So what we should see when we're done here is we should see stuff happening. So let's see if we actually see any of that. And we should see the flow field get written to and everything else. Oh, okay. That makes sense. Hmm. Didn't seem to do what I thought it would. I mean, it's close, but it looks like it's off. I would have expected the writing here to go and actually work. Like, this one looks like it will work properly. This one doesn't look like it worked properly. I would expect all those to be... I expect everything in this box to be the same color. So maybe I need to not blur any of those pixels or something like that. Let's put a bool on this for, let's say, object pixel, and we'll say false. Let's log some of this out. The parent direction is %f, %f. Of %s, and I think it's what, object dot im name. Snag that. Alright, or pixels sub index dot object. I think that's true. Alright, well what I'm going to do is I'm just going to write the tier, not the tiered average pixels, I need to write the flow objects. Well, I don't really keep tabs too much on Adam stream stuff because I'm usually busy working, to be honest. And I'll probably be jumping out of here in another less than an hour. So I'm hoping I can get some of this sorted out before then. So we'll check the flow field. We'll generate all this garbage down. Alright, so it looks like we wrote that guy properly. Like, he's all written as you would expect with a radial sort of flow field thing. But I'm not seeing this box doing anything good. Like, nothing got written, did it? No, not at all. Alright, well I'm going to go to my water here and put the tick number at 1 so we don't have to sit through that every single time. Let's go take a look at this real quick. So our boxes aren't getting written to properly. So we have inputs, repulse areas, and outputs. Let's check our parent direction here. So parent direction of sinkhole is 0, 0. Parent direction of waterfall is nothing. Well, okay, that's gonna make tons of sense. The sinkhole's getting written, but it's 0, 0. So why is it 0, 0? Let's just run it real quick and see exactly what we're getting. Maybe it's because it was off the edge or something else. So let's see. Constructed, tick, generate. So this object is waterfall in, this object is sinkhole, parent direction. So the position is blah, the direction is 1 in the x. So SX, SY, EX, EY? Alright, so it is a box, so get grid square for world position. Position.y. This direction is 1. So why is this getting all sorts of messed up here? So we got SX, SY, EX, EY. It's like we got uninitialized data or something else going on here. Like, I don't understand why we are... Like, it should be top right times map width and all that sort of stuff. So there's no like clamping or anything else going on that would screw this up. It's like, what? Like, we're in the X and Y too, so like we should totally be on this. I must have something simple wrong. I mean, it should just be in the X direction. Based on this, it should just be 1 in the X. Come on, let me search, you piece of garbage. It's saying SX, SY, and EX and EY are the same. But they're both at 504,277. Hundred's not big enough. That's what's going on. They're both the exact same pixel. Yeah, it makes sense. 100 is like 1 meter or something, so it's just not far enough. And why are they the same pixel? Well, because they're right next to each other. They're in the same place. Yeah, that makes sense. Alright, and that is definitely what you'd expect for that to get written in there. Alright. So this is what it looks, let's see what it looks like before we have our averages, and I'm just going to put all these a little bit back on at a time. For the tiered averages, we need to write in the other objects too, don't we? So the tiered average wasn't taking into account a lot of this stuff, which would have caused a lot of problems. His schedule is a troll. Yeah, my schedule is all over the place. I really don't try to hold a schedule. If I was holding a schedule, well, I'd probably have more people watching. But I don't know. Then it'd feel too much like work. Not as bad as John Blow. Alright, so that's looking okay. How come the particles didn't actually get written? Because we didn't simulate any particles, that's why. Well, let's simulate some particles. When he streams games, it makes you sad. Which part of it makes you sad? Just the games, or him, or just are you just sad in general? All right. So for this guy, we're going to change these ticks back to 50. Construct that flow field, we'll tick it and generate it and take another look at it. When programmers streams game, they aren't programming. Yeah, they should be working, right? That's how dare they? How dare they do anything except work on game stuff? Alright, that's starting to look pretty good. Alright, let's fill in the rest of this. So red arterial average, then we'll blur them and blur them. We'll see how all that shenaniganry comes on. Did I not set this thing correctly? Did I not save it? Yeah, I didn't save it. So tick our particles will generate our flow field. And let's see it actually look non-crap. That would be nice. Well, I think that's actually working. I think that's looking alright. Yeah, that's looking okay. That's loading Unreal. If you want to see the asset load time coupled with the game load time, it's going to look more like this test build, where it's got to load the engine and then probably that black screen is the actual asset load time. But it does a bunch of other stuff kind of the first time. It's loading quite a few assets, and I'm caching stuff like that, so I'm not really worried about it. It should only be like 1 second or 2 for a level or less, because we're not. It's going to be all pre-computed, load into memory, so it should be pretty quick. Alright, so that'll be flowing there. That'll be flowing there. It's there. Alright, so we need our magnitude stuff going on now. So what I want to do is I want to change this material real quick. And let's just make this grayscale. Oh, what? Adam went live earlier than he normally does? By an entire hour. What? Well, there you go. So this is the magnitude stuff right now. And I have absolutely no idea what the hell it means, because I haven't really looked at it. But it looks like we do have some information getting written to the magnitude. Which is actually kind of cool. Like, alright. We got something going on already. I don't know what the hell is going on, but it's something. So it's the magnitude that we currently have divided by the max magnitude clamped to 0 to 1. So higher numbers are whiter. So higher numbers are whiter. So obviously we've got some just trash going on here. Though not quite. It's not quite trash. Like, the edges of the shore are actually proper. It's just right here is total shit. Like, this is just all trash right here. But this isn't completely trash. Like, it's kind of there. So, okay, it's looking like our particles are screwed up for some of this, but some of it's not. Like, we've got stuff looking okay. Anyway, I'll have to fix all of it. Anyway, I'm gonna check on stuff. So, now that we've got basically the material set up, we should be able to actually start calculating some of this. Is the simulation just on the surface? Yeah, the simulation's only on the surface. We're not going to have like 3D water you can like jump into and swim around in. Absolutely not. So, it's all surface stuff. And there's also not too much information that I can really get right now with the rest of it. Like, I've got the depth and everything, but So I'm gonna need to figure this out. So I need to write the magnitude of these things in for all these things. Like, you know, we've got our magnitude getting written. Obviously the magnitude is screwed up for the particles. So let's do like a college try real quick to mess with these things before I have to run out of here. Okay, so for the short edge, what we're going to want is the magnitude that we're going to write. So we have the short edge magnitude. That should be a small number. No, we don't need... We don't need this dir times mag, like, we just don't need... Let's just have a small magnitude in there. All this is just trash, isn't it? We're not actually using any of it. Pix.rights? Are we even using Pix.rights? Yeah, it's just... No, we're not. Alright, then the... Write particles to flow pixels. What are we doing for the magnitude there? We're not doing anything with this, are we? You want to search for an object using either a name or a GUID. The only thing you can think of is two hash tables. I mean, yeah, it depends on how much memory you're working with, but yeah, if you have a unique ID string or whatever, you know, just run a hash function on it or whatever, and then you can just look it up. And yeah, that's pretty much what you're there for. That's what they're good for. You know, a tree is going to have log of n or whatever, so hash table is kind of what you're looking for. But if you got infinite memory, just have an array from 0 to maximum value. And you just say, oh, well, you're obviously right over here. So I'm thinking about these particles. I don't really like... Because for me to know that this particle, the speed of this particle, I have to have like the initial velocity or something like that. And then like the distance traveled and everything's like, I have to know I was spawned from a specific path, and that would give me the speed. Otherwise I'd have to do a you know, a density calculation sort of thing. And I think I'm going to have to do the density and have to write the output speed to everything, write the density stuff, blur the density, and use another, you know, data structure there to hold the density, you know, in the grid shaped structure. Because these guys shouldn't actually contribute much to the speed. I mean, I guess they should give a little bit, but the particles should only do anything for speed. You know, up to a certain amount. If they were actually spawned from the line that is the search space line. I mean, pretty much anytime you want to look up there, it's, you know, a hash map of some kind. I mean, that's just kind of your answer in generic land for doing lookups, is, you know, pretty much that. The more interesting things are like have something with a constant time lookup, but also have like a constant time remove, or have like, you know, get next or some other things where you can like preserve order and keep things sorted. And those are the more complex data structures. Anyway, I don't think I'm going to be able to get started and then get finished with anything here real quick. So why don't I just figure out the plan that I'm going to do for the flow field here. So I think what I want to do is, for magnitude, I think I want a separate pass kind of for all of it. So for magnitude, the shore writes a small number. This will be a passed in constant mag. Then what we're going to do is write the flow field. Now we're going to write in the particles. Alright, so particles need to know their starting magnitude, which is from the source input they spawn. So particles without input, the random ones, need a small constant magnitude, and particles multiply their input